Yeah, so basically these are the main requirements that you should have. So any
Mm-hmm.
PC i3 processor also will work. So basically all the
Mm-hmm.
requirements for a Catia software is very minimal, and like
Mm-hmm.
this. So what I was saying is for SolidWorks, if you're comparing like if because all the 3D modeling softwares won't be same. So if you see this and if you think all the softwares is like that, then it'll be a problem. So I'm telling you the example for SolidWorks also. So in the
Mm-hmm.
case of SolidWorks, you need at least the 18 8 minimum is least 8 GB RAM. Okay, 8 GB
Mm-hmm.
RAM is a minimum. Then you need at least
Mm-hmm.
20 GB of hard disk space.
Mm-hmm.
Then you need NVIDIA Quadro graphics. Okay, you can
Mm-hmm.
write it down. Quadro graphics is one which is used for 3D modeling and everything. You have the GTX, you know GTX graphics, 1050,
Yeah.
2520, all those things is for gaming laptops. So
Yeah.
gaming,
I have a GTX
yeah,
1080.
1080, okay, minus 1050, okay, auto. So all those things is for gaming. And when it comes
Mm-hmm.
to high level 3D modeling or 3D design, you'll have to go
Mm-hmm.
for this thing quadro graphics. Okay, quadro graphics.
Mm-hmm. Okay. Photographer.
Yeah, so that's like 2000 series, 3000 series, like that will come. Basic is 2000 series. So you get it
Mm-hmm.
in both AMD and in this thing you get, NVIDIA you get.
Mm-hmm.
You get in this two you get it. So that is the one which is used for all like all design, be it for mechanical design or be it for civil design or be it for this thing all movie making is that right or like what is it audit or Autodesk CFX and all those things, all those thing whatever like job related things and everything which requires a lot of this
Mm-hmm.
uh, power, that quadro graphics is used. And just for
Okay.
gaming we use GTX graphics. So GTX,
Mm-hmm.
what happens, the frame rate will be more faster. That's it. Okay.
Okay.
So moving on to the next, what is next? Introduction. So, this things. Mhm. So, okay. So basically, I'll give an overview of Catia software now, how to turn on.
Mm-hmm.
And so basically, to turn on Catia software, you can just right click on the desktop.
Mm-hmm.
You can go to new. Here only you'll get Catia part, Catia drawing, Catia product, Catia function systems, and everything. From here only you can turn on Catia. Okay, that is
Mm-hmm.
one way you can do it. And one more thing, I'll just show you how to just install it. So if you have this Catia software, what you have to do is just directly install it. You do it right
Okay.
now. Do it right now.
Oh, okay.
So yeah. So if you have it
So
in
I
your hand,
have I have Catia V5 R20 opened. So should I install R21 too?
yeah, R21 is the latest version, like updated version of R20. So what happens? So yeah,
Okay.
one more thing which you should remember, you can make a small note about it. Whatever drawings you do in
Uh-huh.
R20, you can't open in R21. Whatever drawings you do in R21, you can open in R20. So that is one big headache.
Oh.
So Katia has one big headache like this. So the problem, what happened is like the real life scenario in Boeing,
Mm-hmm.
right? They what do you say? They replaced the software with the latest updated software. Okay, so these people are
Mm-hmm.
using the same thing, like five R Catia 5, and when they updated it,
Mm-hmm.
literally all the models what they did or got corrupted or something, and they had to incur some 1 billion loss
Oh.
for Boeing company because of this
Oh.
Catia's this upgrade and everything. So
Okay.
that's one thing you should remember. So always when you're using some other system, you should always see is a version that you're using same as that in that system or not. So all those
Mm-hmm.
things you should observe carefully and then you should proceed. Else you may think, okay, I
Okay.
have this thing and I will do it from my home and I'll just go put it there. It is not going to work. And one more example, my example I'll give you. So when I was learning this software, right? So we had a project,
Uh-huh.
right? Yeah, we have a project in the sense
Uh-huh.
like final in the end we'll have to give a project. So in that project what has happened is I did some in my institution and some are
Mm-hmm.
from my home. I did it in the final assembly, so some 25 piece parts were there. So I did
Mm-hmm.
most of parts from home and some from the institute. And
Okay.
what happened is at the final thing when I'm trying to assemble it, I couldn't upload the files which I did from my home into that system. So
Okay.
those things got corrupted there and they were not opening. So I had to redo everything. So you should
Oh,
be very careful when you're playing around with these versions. Okay.
okay.
Yeah.
Like it is just one version different and still it is
Yeah.
playing.
Still, it's very problematic. So you should
Okay.
be very careful with that.
Okay.
So yeah. Next, how you like I was showing how to install it. So what you have to do is basically it's very easy to install it. So you just have to what do you say?
Yeah.
I think you know the installation procedure, right?
Yes, I'm currently doing it.
You just have to install it. Then you have to just open the crack file and just copy paste it. That's it. Nothing else.
Okay.
No second.
Uh, do I have to install online documentation?
Nah, it's not required.
Okay.
You just have to just see setup. You have to click. Then you'll have a crack file, and
Mm-hmm.
then you just have to copy paste in the. So you have to just right click here.
License.
Yeah, you have
Uh-huh.
to just right click here. Open file location. Over here, you have to
Mm-hmm.
just copy paste it. Then you're good to go. As simple as it
Okay.
is. Srivardhan, oh yeah, you're new to this batch, right?
Just mute it.
Yeah. Srivardhan, am I audible? Base माटा में क्या? So the next way to open this is you have to just go here in your search thing. You have to just type Catia. So here you can directly access it. Here also you can access it. Or else the next thing that you can do is from here itself you can
Double
see the
click.
desktop. Yeah, double click it. So just double click Catia V5 and it'll take some 1 minute or 2 minutes and it'll open. Or else, like I said
Okay.
before, just go to new. You can open Catia part from here.
Mm-hmm. Open part design.
Yeah, you can it'll open the part design. So totally, how many workbenches are there as per yesterday's discussion?
Uh, well, there is sketcher, there is part, there is assembly, there is sheet metal, there is surface designing, there is drafting.
Hmm. So what happens in Sketch?
Sketch is just quicker, like you do the 2D thing and you apply constraints and everything.
Hmm. What all
And
types
part
of
design is where
constraints?
you.
What all types of constraints do you apply?
So there are like two constraints, dimensional and geometric.
Hmm.
Dimensional is just applying for dimensions, and it should be constraints so that you know it is based on like it is like parallelism based on angles, perpendicularities,
Mm-hmm.
concentricity, something like that, right?
Mm-hmm. Yeah. So those terminologies are important for one more thing. So do you know GD&T? Have you heard of GD&T?
Yeah, yeah, yeah.
So
I have taken a course in that.
yeah. So you'll know all the 12 different types of GD&T symbols, right?
Yes. Uh-huh.
Can you name few?
Like the whole and everything.
Yeah.
Wait, taken notes from it. Let me just refresh.
Because GD&T is very
Okay.
critical.
Mm-hmm.
Yeah. So because if you're doing drafting, right? So one
Mm-hmm.
thing is you should be very what do you wait. You should know GD&T symbols perfectly because like I told you yesterday, right? When you're giving
Mm-hmm.
some model to like some drafted image to some manufacturing person, so he
Mm-hmm.
should totally understand what and where it is. Like see, in most of the things like surface finish, all those things cannot be shown in 2D drafting. It cannot be shown in 3D modeling also. It's very difficult to make them understand key this has to have this finish and that. So GD&T
Mm-hmm.
symbols comes very handy. Like for example,
Like straightness, flatness,
yeah,
circularity.
exactly, run out and everything. So it's very critical. So they, it's like there is no way to communicate with them apart from telling them by word of mouth. See, I need
Mm-hmm.
this flatness here. So every time it won't work. So if you're storing
Mm-hmm.
the details in your file, after 5 years, the person will take okay the same component you will manufacture. So he'll take the file and he will manufacture it. So in the initial stage when they manufactured, they knew that they needed this flatness, they needed this total runout and everything. But in the file,
Mm-hmm.
it's not if it's not mentioned. After 5 years, they will be like they won't know if that is a requirement. So they'll just give it for manufacturing without giving those details. And what will happen? So
Yeah.
there'll be a problem, right? So that's why we have
Mm-hmm.
these GD&T symbols. So like for example, I'll give you one example, like real life examples. So you have two things. You have a bottom, like if you're taking my thing, I'll tell you, cold plates. So you have a housing, bottom housing, okay, and you have a
Mm-hmm.
top plate. Okay, so what happens
Mm-hmm.
is for thermal management, we have this thing like a case inside which we put fins, plate fins or plain fins or VV fins or offset OFC fins. So we have different types of fins. We'll stack them inside. We'll close them and we'll vacuum raise it. So what happens is if in case we have not specified the flatness of the mating faces. Okay, the top face mating face and the bottom side of the top plate mating face. So what happens is if flatness is not there, we won't get a proper brace joint. Okay, then the whole product what we have done
Mm-hmm.
is a total waste. Just for one thing, okay, just for mentioning a flatness like zero point 0.1 flatness at this location and zero point 0.1 flatness at this location, only for not mentioning you lose some 30,000 rupees for it, more than that. Like for bracing cycle it's 60,000, so more than 1 lakh,
Oh,
1.5 lakhs you will waste just for not mentioning this. So
oh my God.
it is that critical. So I'm telling you the criticality of these things. So when we learn it, we don't know where it is used, why it is used, what is the criticality. We just learn because somebody is telling us this is that and this. Okay, so we don't have that seriousness key. Okay, this is so important. Like that, we don't have that feeling, right? But in reality, when we
Mm-hmm.
are doing those projects, that's when we realize ki, okay, these things has to be considered. If it's not considered, this is gonna happen. Okay, understood?
Mm-hmm.
So
Yeah.
it's a big loss for the company if is anything like this is missed out. So if you mention the
Okay.
zero point 0.1 flatness, what they will do is after the CNC operation is done, they will
Mm-hmm.
take it to the surface table. There they have a dial gauge for checking the surface flatness. So using this dial gauge, they will take the surface flatness of each and every region. Okay, at that point, so they
Okay.
will see they'll set one point as zero, and they will
Mm-hmm.
run the dial gauge. So if any fluctuation or
Okay.
anything is there, they will note it, and they will do
Mm-hmm.
like if possible, they will do the grinding operation. Okay, they will grind
Okay.
0.1 mm or something, and they will try to achieve the flatness that we require. Okay,
Okay.
0.01 or something like that, and they'll achieve the
Mm-hmm.
flatness. If you don't
Okay.
mention it,
Sometimes it
yeah,
sometimes it will be difficult to achieve that flatness, right?
yeah,
So
it is.
what can we do
See,
in
it's
that scenario?
when it's difficult to achieve. It is very difficult to achieve if the product size is 600 into 300 or 900 into 300. When the product is very long, okay, that's when it's very difficult to achieve the flatness. Because when you clamp it now, what happens is there'll be a bend anyways. So it's very difficult to achieve it when such a thing, such a scenario happens. If it is a small 200 into 200 or 500 into 500, for 500 is also difficult, but 200 to small part, right? Then it's not a big deal. It's easy to achieve the flatness. So if
Mm-hmm.
you're not able to achieve the flatness, you'll be able to achieve it like to some certain degree you'll be able to achieve it. Yeah, it's very difficult. Yeah, if it's like material like SS or something, it is a little difficult. But when it comes to aluminium parts, it is even yeah, even that is very difficult. But somehow they'll achieve it. That is what I said. Using the grinding operation, they will try to achieve it. But still,
Mm-hmm.
there will be some fluctuations, 0.01 or something. So for that,
Mm-hmm.
what we can do is we use a filler, right? We'll use a little more
Mm-hmm.
of a thicker filler. Like if you're using zero point 0.1 filler, we will use zero point 0.2 filler. So the
Okay.
thickness, see, like whatever fluctuation is, it will be like 0.02, 0.05
Uh-huh.
in that range. So if you're using a zero point 0.2 mm filler, so that will subdue it, right? So that will
Okay.
take care of it, and we'll clamp it to really tight so that the brace joint is strong enough. So that is the only
Okay.
thing that we can do. Yeah, as you said, it's not that easy to achieve the flatness,
Mm-hmm.
but still they will try their maximum. If you don't mention it
Okay.
after CNC operation, they will just give it to you right away without
Okay. So
checking the
as a
flatness.
mechanical designer, you should know, what manufacturing process they are doing and how much flatness they can achieve, what material, with
Exactly,
what material you can achieve and everything.
exactly. You should
So you
know.
have to do your homework before.
Yes, exactly. You have to know all the metallurgy, what it is, how difficult it is. See, because like for aluminum, for example, I'll give you. See, aluminum material is very soft, right? So what happens is
Mm-hmm.
when the machine cutting tool is running at it runs at 7,200 RPM, so it's very fast. Okay, so when it's
Mm-hmm.
rubbing against it, there's a lot of friction. Okay, there is lot of friction, and this friction creates heat. So when aluminum is soft material, when this heat is generated, it'll automatically, what do you say, expand. Okay, it'll expand because of the heat. I think you have seen CNC machines, right?
Mm-hmm.
You have seen the white color liquid that comes out.
No, I just saw the machine. I
Yeah, so
haven't like gone.
when it's running, there's a white color liquid which runs
Okay.
and hits the thing. So that is actually the coolant. Okay, that is
Mhm.
coolant. The reason why they use coolant is because of this friction, there's a lot of overheat. So when it's
Mhm.
overheating, the metal automatically expand and it'll bend. Okay,
Okay.
so that's why they
Mhm.
use maximum like three or four nozzles will be there, which will pump all the coolant, and it'll try to cool the
Okay.
job, or else the whole thing will bend.
Okay.
Okay, even that also you have to consider the heating, because if the thickness is very less, it'll bend much more easily. So there's so many factors which is involved, and GD&T is one thing which you should know perfectly before doing it.
Okay.
It's like runouts, the flatness, the parallelism, the symmetries,
Mm.
all those things. See, if you have the symmetry thing, like if you have a plate, okay, if you have a plate with holes in this side and holes in this side, and they are in symmetry, so you don't have to mention the dimension for this side and this side. If it is a symmetry, you can
Mhm.
directly just show this side as symmetry to
Mention.
the other side.
Mm.
So you can
Okay.
just mention the dimension on one side. So it'll save the space that you required for drafting, and it'll make it much
Okay.
more simple for them to understand. So any drafting that you do, you should be able to recreate the model yourself. Okay, in a simple manner. So every time you see a drafting, right? When you do a drafting, just think, "Ki as a manufacturing person, how am I going to manufacture this thing?" So like that, you have to think. Okay,
Okay.
so many things that is involved. I will share my maximum experience with you. It's not a big thing.
Okay.
So you'll get more insight into what is the things that go inside an industry. Okay.
Mhm.
So now
Okay.
when you open Catia, you'll be entering a page like this. Okay.
Just a
So this
second.
is,
I'm
yeah.
launching.
So Srivardhan, am I audible?
Hi. Yes, you're audible.
Yeah. Can you give your
So yeah, this is my first class,
yeah.
uh, and could you tell me where I could download Catia from?
Catia, the support team will share it to you. So you can just take it from
Oh,
them
right,
and
right,
you can
okay.
just install it. So can you just
Right, right.
can you just introduce yourself?
Yeah. My name is Srivardhan, and
Mm-hmm.
I graduated with a master's in mechanical engineering last year
Mm-hmm.
from the University of Illinois at Chicago.
Okay.
Yeah. So that's it.
That's it. Where in India?
So,
Where are you from? Like in India?
I'm based in Chicago right now.
That's okay. Like just 2 years back you went there, right? 3 years back.
No, I graduated in 2020.
That's okay. Like where do you stay in India?
Oh, in India. Oh, right, right. So I'm from Hyderabad in India.
Okay, Hyderabad. Okay.
Yeah.
Telangana, Hyderabad, or Andhra Pradesh, Hyderabad?
Uh, it's in Telangana.
Telangana. Okay. So how many
Yeah.
3 years back you went, right?
Yes. So I finished my BTech in 2017,
Which
and
college?
then it's called CMR College,
Okay.
and I came to the US in 2018,
Mm-hmm.
and graduated from that in from masters in 2020.
Okay. And
Yeah.
what are the softwares you know?
Mainly, I'm mainly proficient in SolidWorks,
Mm-hmm.
and I did some FE work in ANSYS.
Okay.
I also worked briefly on Creo
Mm-hmm.
and Autodesk Inventor as well.
Okay.
But actually, on Catia, I have no idea though.
Okay.
I've never worked on Catia.
Catia, the thing is like if you know Catia, all other softwares becomes very easy. That's what
Okay.
advantage of Catia. Catia is like the grandfather of all 3D modeling softwares. And
Right. Yeah.
the way it behaves is also like a grandfather itself. It won't listen to
Okay.
you, and it's very irritating to work on sometimes. But I'll make
Mhm.
sure it's very easy, as simple as possible. Because when I was learning this software, it was like literally I didn't understand anything. SolidWorks is
Mhm.
like very easy compared to this. Any other software is very easy compared to this. So literally, I had a tough time learning the software, but
Yeah.
I know the shortcuts. I'll teach you all the shortcuts. I'll make it as easy as possible. I don't think you'll find it difficult the way I'm teaching you guys. So only thing which what I require from you is you guys should practice it. Okay.
Right.
So I'll teach you in a simple manner. So you'll think it is easy, but in reality, what happens is like when I'm teaching you, right? It'll be easy, but when you're doing it, you'll find a lot of difficulties. Okay.
Mhm.
So you have to practice it, so you'll understand it. And since you
Sure.
know, so like, have you worked somewhere after this thing? Like, have you worked anywhere,
Sorry.
or or have you like after engineering you just went to do masters?
Yeah, I did work in one place, as a mechanical engineer,
Uh huh.
but it wasn't. I wasn't mainly dealing with creating CAD software.
Uh-huh.
So yeah, um, it mainly had to do with um, estimating what kind of pumps to install,
Okay.
and I worked at a pump dealership, water pump dealership.
Okay. Okay.
Yeah, so I did work on some finite element analysis in that job,
Uh-huh.
but computer-aided design was not very much used.
So in ANSYS, you are using structural or CFD? I think CFD, right?
Uh, no, it was actually structural for the mountings and
Okay.
vibration analysis for the pump
Okay.
mountings.
Okay. Okay.
Yeah.
Okay. So okay. Fine. Fine. So okay. Fine. So SolidWorks, you are pakka with it.
Yeah, I'm pretty good with SolidWorks. I've
Okay.
also briefly learned Siemens NX.
Yeah. NXCAD. NXCAD is my favorite. I like it. Yeah.
Yeah, that was pretty good. Yeah.
Yeah. So NX and Catia are like two big brothers, and NX, their
Mhm.
the company puts a lot of effort in improving the software, and the level to which it has reached currently is
Mhm.
way high. Like now we have NX 11 8.5 like that, right? The latest version
Yes.
is NX 8.845 something like that, and
Yeah, right.
that yeah, so that is like way ahead of its time in when it comes to design. And worst thing is they are like in like so that people don't pirate the software, they're making it all cloud based. Even Catia
Yeah.
also we have 3D experience, so which is again going to be cloud based. But when it comes to
Mm.
NX, they're incorporating every single aspect of design, from planning to manufacturing to cost, that this every single aspect of design they're trying to
Yeah.
incorporate into the software, and they're putting a lot of effort in changing it. So yeah, that's one thing. So even Katia, we have 3D experience. I think you'll have heard of it. Even that is the latest trend actually. Yeah, Katia. One more thing about Katia is it's a brand value. Okay, when it comes to Katia, it is like it is one of the oldest software. It's like iPhone of this thing, the mechanical
Catch
world.
up.
Yeah, CAD softwares, iPhone of CAD softwares. So that
Yeah.
brand is there always. So all the big companies they still use this. Even if they don't like
Mm.
it, they'll keep using this because of the brand. Because when they say they're using Katia, it's a brand. So the moment you open, so Satyaprabha, have you installed it?
Yes, I have.
Okay. So when you open it, you'll be introduced to product one application. So this is nothing
Mhm,
but your assembly workbench. Okay. So in assembly workbench, this is the first page you'll be entering. So you don't want this, right? So what I'll do is I'll directly close this. So here we can see there's two close. One is for the entire thing and one is for the workbench. So you can just
mhm,
see restore down. You can make it small if you want. You can enlarge it like this,
mhm,
and you can do the
mhm,
drafting here or something like that. You can do it, or else you can just get rid of this completely. Just close this. Okay, so now we are empty. So in
mhm,
empty, you can see here you have control N. That is like basically same for anything. That is to open new. Then here we have opens already existing files. If you want to open, you can click this. Rest all these things are turned off because save you don't have anything to save, so it is
mhm,
incomplete. Print you don't have anything to print, so that is inactive. You have see cut, copy, paste, cut, copy, paste. All these things are inactive because you don't have anything to cut, you don't have anything to copy, and you don't have anything to paste on. And here we have undo redo, even that is inactive because we don't have anything on the screen. So now what I'm going to do is I'm going to do control N, and I'm going to bring a new page. So control
mhm,
N, or you can just directly go to start. Okay, so first I'll
mhm,
explain this. So don't see this. Okay, these things I have given the shortcuts. So don't see
Mm-hmm.
this. Here you have to see. See your thing will start from here. Infrastructure, mechanical design, shape, analysis. So from here, it's going to start. So in infrastructure, you have product structure, material library, Catia V4, V3, V2, the older previous version files. If you want to put, you have to put it here. And then
Mm-hmm.
catalog editor, then photo studio, like
So
infrastructure.
the previous version file can be opened with that, or
Yeah, yeah.
what is it?
See, latest version
Okay.
file cannot be opened in V4, V3, or V2. Okay, if it's V5 version, you can't open it in that. But
Mm-hmm.
you can open the older versions in a higher version. Okay,
Okay.
older versions you can open in higher version. Same with other
Mm-hmm.
softwares also. In SolidWorks also,
Yeah,
if you have Catia SolidWorks 2015, those files will open
yeah.
in SolidWorks 2018, 2020.
Mm-hmm.
But the opposite won't happen. Okay. So in
Okay.
infrastructure, again you have Photo Studio, like again for rendering applications. You know what is rendering?
Yes, yesterday you explained me.
Yeah, that yeah,
So we
animation.
have rendering here itself.
Yeah, here also you have rendering, like Photo Studio. You can place the object in between, and you can take photos with side walls and everything. See, Photo Studio is here. Then here,
Okay.
real time rendering is there. Like again, rendering option is there. So like that, we have
Okay.
some
So
extra.
real-time rendering, you can record videos and all.
It's very minimalistic. Again, it's not that advanced.
Okay.
Yeah, normal photo rendering only is enough. That comes good. Apart from that, it's not that great. You'll have to use some
Okay.
third-party software again to do that, like Keyshot or something you can use. Then here we have mechanical design. Mechanical design is the main core which we'll be working on. Like we discussed yesterday, we have part design over here, assembly design over here, sketcher
Mm-hmm.
workbench. Okay, part design workbench, assembly workbench, sketcher workbench,
Mm-hmm.
drafting workbench, generative sheet metal workbench, wireframe, and surface design. All the six workbenches which we are going to deal with is in this mechanical design option. Okay, so here you can
Mm-hmm.
see sheet metal design, part design, drafting, sketcher, wireframe. So whatever is required, I have put it here. That's it. Okay,
Okay.
so these are the things which we'll be using. Then next
Yes.
comes yeah. So this I'm just giving you for an idea. So we have shape
Mm-hmm.
design. In shape design, we have freestyle, sketcher, tracer, imagine shape. So all these things are actually really helpful when it comes to
Mm-hmm.
wireframe design. So here we have this wireframe and surface design, right? So it's very
Mm-hmm.
what do you say, limited in options. So if you want more options, you can directly jump to shape. While doing that as well, you can jump to shape, and you can go to any of these things, and you can enhance the design that whatever you're doing. Okay, you can
Okay.
enhance the design whatever you're doing. Then here we have analysis and simulation. So in Catia itself, you can do the structural analysis of the whatever thing you have done. Okay, whatever
Yes.
model you have created, then and there only you can do the structural analysis. But
Okay.
this will not be 100% accurate. You'll get a
Mm-hmm.
mild idea of how the product is, what are the changes that
Okay.
you have to make, and how you have to improve the design. So this is
Mm-hmm.
like small things you'll get. Then here we have AEC plan, like plant layout design and everything. Then here machining, CNC machine. So here we have lathe machining. NC, STL is what? Do you know where this format is used? Dot STL?
STL, is it in SolidWorks?
Nope.
No. No, no. Rhino or something?
No.
I
So
have no idea then.
basically rapid prototyping. See here you can see it's given rapid prototyping. So in
Okay.
which the things that you should know as a mechanical engineer is, so even you should
Mm-hmm.
update by time. Okay, in like whatever like trends are there in the like 21st century. See, As the
Mm-hmm.
like in every 5 years there is a lot of changes that's going to come into place. So you should keep
Mm-hmm.
improving the database, like what knowledge you have, that you should keep increasing. So if you take
Okay.
any companies, for example, right now, all those companies, they have, see, any product before coming to market, they have prototyping. They prototype the model. Then once the verification and validation is done, okay,
Mm-hmm.
once the verification validation is done, then only it's going for manufacturing. So rapid prototyping, basically what we use is additive manufacturing. You know what is additive manufacturing?
Yes. 3D printing.
Exactly. So 3D printing. So 3D printing, to do it, anything, any 3D model you have to do is 3D printing model you have to do is, then you have to be it SolidWorks, be it Catia, be it Autodesk Inventor, or anything. You have to save the file in .stl format. Okay. You can make a
Okay.
note .stl format. You have to save the file. Once the file is
Mm-hmm.
saved, you can just give it for 3D printing. Understood?
Okay. Yeah. So, what is the purpose of putting this in lathe machining? Like, what are we gonna do in these options?
So basically, see, machining means like if you have a product, okay, if you have a product
Mm-hmm.
in place, see, like olden days, if you have any design, so you know how NC programming works, right? G codes, M codes, and everything. You have studied it in your engineering, right? You give G91, then you have to go here, then you have to
I
give
didn't
X
do
axis.
mechanical, so I don't know actually.
Yeah, so what happens is you have to give it like a proper trajectory for the lathe machine. Okay, so it's a
Yeah.
computer, right? So in computer, what
Yeah.
happens? See, even for 3D printing, you had to see the probe moving in X direction and Y direction, right? It'll move
Mm-hmm.
X, Y, then it'll do the model. Right? You have seen that,
Mm-hmm.
right? So
Yes. Yes.
what is happening is it's a code. So in the
Mm-hmm.
lathe machine or milling machine, the product,
Mm-hmm.
the dial, okay, it has, we have to give a code, like in X axis it has to go 100 mm, then it has to go 200 mm in Y axis, then it has to come back at 100 mm x minus 100 mm X axis, then
Mm-hmm.
the dial will go in that direction. Whatever program we give, in that direction it goes. So what happens is you
Mm-hmm.
have to sit and write down the programs. Okay, you have to sit and write the programs down. So in since you have the software, what it does is you just put the model here, and you just go for this prismatic machining or surface machining, and you
Mm-hmm.
just apply the whatever tool you're using, whatever time. See, tool availability is also important. You have like plenty of thousands of tools, different tools, so you have to specify which tool you're going to use for this particular operation, all those things, and they'll give you some suggestions also, and according to the tool they will generate a tool path, and that tool path will have an NC program. So this NC program can directly be transferred to the CNC machine. So you'll give this NC
Mm-hmm.
program and you'll put a block, as aluminum block or any job block, and as per the NC program, it'll remove the material. Understood?
Okay.
So NC means numerical control program. Okay, so that is
Yeah.
how
Yeah.
it's done. So digital mockup here means kinematics. Kinematics is like checking the movement. So if you're
Mm-hmm.
doing some link, like I told you yesterday, so you have to be sure that links are working fine and is serving the
Mm-hmm.
purpose for which you are installing it. For example, if you
Mm-hmm.
have a wiper or something, you have to see properly key if it's all the gear is working properly, and it's putting enough torque on the thing, and it is moving in the angle that is as per the requirement or not. So you have space analysis, kinematics, how it is going to move the thing and everything. You can do it here. So again, it's a mock-up. So kinematics, you can check all this things like piston movement, all those things you can check. Then equipment and
Okay.
system, here it's purely HVAC. What is HVAC?
That heat ventilation.
And as circulation. So When that is like if you go to any buildings, okay, any apartments or
Mm-hmm.
anything, every single building will have this thermal management HVAC systems.
Mm-hmm.
So HVAC systems can be done using this equipment and systems. So here we have tubing, structure discipline, HVAC discipline. So different options here we have. So circuit board design also you have in this. Like because electrical component, not just buildings. In this we can create. See if you are using like ATR chassis. ATR chassis is, you know
Mm-hmm.
what is ATR chassis?
No.
So in defense and aerospace, we use a standard called ATR chassis. So an ATR chassis is a chassis which is used in all fighter aircrafts, all different aircrafts. Okay. So what it is basically it is aircraft transport rack. Sorry. Sorry. So what
Mm-hmm.
happens in this is we all the motherboards, all the important critical components in an aircraft is put inside that, and a cooling is provided for that. Okay, it will be like you're safely packing all those things in one place. So because in aircrafts you can simply randomly put all the components. If you see some machine or something, okay, in
Mm-hmm.
ground level, if you open that box, all the wiring will be here and wiring will be there. All different things will be here. Everything like if you have opened a panel, have you seen a panel anywhere?
Which one?
Like panel, electrical panel.
Panel. Yes.
Yeah, so
Uh-huh.
if you open it, you'll find thyristors, that this everything is jumbled here and there. So everything is in one place, right? If you open the panel,
Mm-hmm.
everything, all the tiles, everything. So the
Mm-hmm.
same thing if in aircraft, if you do it, if some short circuit or something happens, the whole thing will burn. So for that
Yeah.
reason, everything is packaged in a very systematic manner in air transport racks, and air transport racks has standard the same size throughout the world. The size of ATR chassis are same. So these chassis
Okay.
is manufactured as per the standard, and all the hard disk, motherboards, all the electrical components is put in place, and adequate cooling is provided using this. So using this HVAC thing and circuit board design and everything, you'll figure out key which region is providing maximum heat, where is the heat generation more. So cooling will be concentrated at that particular area. So if in case the thing the chip is in the bottom side and it is overheating and generating a lot of heat. So what happens is you'll provide an aluminum extrusion heat sink at that bottom plate, and your fan cooling or liquid cooling will be enhanced at that particular region to allow the cooling. So all those things is done using HVAC systems. Again,
Okay.
tolerancing or annotation. So this thing when your model is created, sorry, when the model is created, you can give the tolerancing.
Oh, so it is just for tolerancing.
Yeah, normally you can just give the tolerance values on that. On the photo model is on the
Okay.
screen, you can give it. Then machining
Okay.
simulation. So in here, you give the machining, right? NC program, everything will be generated. Then here
Mm-hmm.
we have the simulation. Simulation means like checking the toolpath and everything, like how it is going. So you can simulate the program. Or else if you have any other program, you can just simulate it. Simulate in the sense
Oh,
ki how it is going to remove the material and all those things. So you are asking
okay.
about ergonomics, right? The human body.
Mm-hmm.
So that human body can be taken from here in agronomics design analysis. Here you can put the human body. The main application of this is you can see the size of the person, the comfort and everything can be like seen from here. Like if you're designing a car seat or something, it is not practically possible to just measure the thigh size and hind size, leg size, shoulder size, and just keep doing it right. It's not. It's very
Mm-hmm.
difficult. So if you have a human model, so you can keep that model there, and you'll get a clear picture. Ki how much side thigh rest you have to give, how much left side you have to give. So you'll get a clear picture. Ki how much material you have to add or remove. So all those things, like for example, if you're designing a bus stop, okay, so you have to make a seat. So you will
Mm-hmm.
design a seat of 50 mm. Okay, and after you put this agronomics model there, you'll see that
Mm-hmm.
the seed is covering only a small section of his backside. Okay, so what you do is you'll increase the length a little more, like more 50 or 80 mm. How much is required? So only so much you will
Mm-hmm.
increase it, and that will enhance the thing, and he'll have a comfortable sitting position. So you'll know
Mm-hmm.
exactly how much material to be added. You don't have to add more than required or less than required. So as if you have body
Okay.
like this, you can know how much is required, so much you can keep, and you can finish it off. So here we
Got
have
it.
not yeah knowledge where you have this thing. Basically, what it does is like see, there will be some already existing components like small washers or something. So all those things you
Mm-hmm.
can take from here. And one more thing, one more advantage of this is this knowledge. See, you can. One is that. Then. Yeah, you can what do you say? Structure this thing you have, right? Tree specification tree,
Mm-hmm.
that you can
Mm-hmm.
structure it using this. There's some other things
Oh,
also. Some other thing also was there. I don't remember right now. I'll let you know later. So then the
okay.
thing is, and via V5 VPM. So in this only you open all those things, old versions, V4 V5
Okay.
and all you open in this.
Okay.
Okay, so this is the basic idea of Catia, and what are recent files that you have opened. All those recent files will be shown here, and here you have
Yes.
the exit option. Okay,
Mm-hmm.
or else you can close it from here.
Yes.
Then comes the this connector. Then here we have again folder versions. Here we have file. Here you can create a new from any other files. Then
Mm-hmm.
open this like what are existing files you have. Then you can close the entire thing. Then here we have save as, save all those
Mm-hmm.
things. So here again we have recent files.
Mm-hmm.
Okay, edit again, copy, paste, undo, redo, whatever you saw here, all those things you have here itself. Okay, then
Mm-hmm.
here view toolbars. So whatever you want to see in the toolbar, all those things you can add. If you want graphic properties, you can add graphic properties. Now you have the color option, all those things using the
Mm-hmm.
graphic properties. That is the toolbar. What you want in toolbar, that you can select it here.
Mm-hmm.
Then here in insert, right now there is nothing because we haven't selected any workbench as of yet. Then here we
Mm-hmm.
have tools. So in tools we have image. Like in image you can capture photo, or else
Mm-hmm.
you can
Yeah.
take video of whatever you're doing, like that.
Mm-hmm.
So macros is again, it is a program. Okay,
Yeah.
it's a program. So this is C++, and what you can do is you can create a program in Excel and you can just input it. Or else there is something called Naka. Have you heard of Naka?
No.
NACA is again for aerospace, like wing structures, aerofoil dimensions, and everything. We'll get it from NACA website. So those things you
Oh,
can put,
Naka. Okay.
yeah,
Yes. Yes.
yeah, you can put it in Excel. You can put it in Excel, and you can run the macros. So when the
Yeah. Yeah.
macros is run, you get all the points in your screen. So you can just join it and you can just extrude it, and you can get the
Mm-hmm.
aerofoil as per the standard.
Mm-hmm.
Okay, that can be done here.
Okay. Mm-hmm.
Then what is the utilities there? Customize again. Yes, options. We have options and tools. What are options you have? You have it in tools, standards, conferencing, also. Then Windows. What are Windows is open? How you want to open it? You want to tile horizontally? You want to tile vertically? Cascade or new window like that. And help you can take at help. This is totally of no use. If because in SolidWorks, if you just type in search, you'll get all the complete data history and where the position is, all those things. You get the complete picture. When Catia, it's a little what do you say? It's not of any use.
Mm-hmm. Okay.
Yeah. So now moving on to, I'll open the part design, mechanical design. Opening the part design.
Mm-hmm.
So here you'll get a thing. So in this you have to just write whatever you want to write. Example you can give. and enable hybrid design. When this is enabled, you can have like multiple workbenches. Like when you're doing part design, you can shift to surface design. From surface design, you can go to sheet metal. From sheet metal, you can go to that workbench. So you can keep jumping workbenches when this hybrid design is turned on. So you can
Okay.
click OK. So now you are in your part design workbench.
Mm-hmm.
Okay. So here we have these things. What do you call this?
Planes.
Huh?
Planes.
Yeah, you call it datum planes. Okay,
Mm-hmm.
DATM planes. So
Okay.
here we have X, Y, then here this is YZ, and this is ZX. Okay, so if you have used AutoCAD, you will know this plane is XY plane, XY
Mm-hmm.
plane. Okay, XY plane, and this is mostly the top view. All the top views will be done in this plane, right?
Mm-hmm.
And if any side
Mm-hmm.
view you have to do it, you can do those side views and using this plane. And if you want to do
Mm-hmm.
any front views, you can use this plane, that is visor plane. Okay, so you
Mm-hmm.
have to select the planes according to the design, according to the drafting image that you have. Whatever drafting image you have, according to that you have to select the planes. Is it fine?
Mm-hmm. Okay.
So now these are three planes you have, and this is a part body. Whatever you're doing, everything will be added with this. And one more thing you can see when you open it, see there'll be something here, there'll be something here, then something will be closed. The person before you would have closed these things. So you're literally confused. Ki, okay, I had these tools. Where the hell are these tools? And I'm not able to find it. So one thing you
Mm-hmm.
can do is if you go to insert, you get all the options. Whatever options is there in this part design, all these options will be you'll be able to find it here itself.
Mm-hmm.
Or else what you can do is you can right click on any empty space, right click. So
Mm-hmm.
here you have this customize option. Okay, these are
Mm-hmm.
things that you want to add in toolbar that you can add. So now graphic properties I added, right? It is still here. I don't
Mm-hmm.
want that. It is not required, so I'll close it here itself. It's gone. So now I can just right click here. I can click customize from here, or as I showed you in tools, here we have this customize
Mm-hmm.
option. Anyways, like this or this you can do. And one more thing, if you observe, see everything is active now. See save as, all those things is active. Print,
Mm-hmm.
everything is active. Here also every single thing is active. View, so many other options has come into place. Okay. Insert,
Mm-hmm.
so many things. Insert, nothing was there, right? When we opened it last time.
Mm-hmm.
So now we have so many options is there. So in insert, you get all the options that you want. There's the features, everything get it here. I was talking about the customize option. Since everything is some things are closed, so I want everything back. So I'll go to customize. It'll take a few minutes. So over here, you have to go to toolbars, third option. In toolbars, you have to restore all contents. Okay.
Mm-hmm.
Restore position. Okay. If you do these two things, see everything is back into its position, original
Mm-hmm.
position. So you can see this is back to its position. This is back to its
Mm-hmm.
position. This is back to its position. Every single aspect of this has come back to its position. Okay. See
Yeah.
whatever had closed, all those things has come back. So
Mm-hmm.
it's very important to do it before itself.
Okay.
Okay. So even the position is restored. It's the
Mm-hmm.
advantage. So here, so many tools we have. In the bottom also, see here you have new, open, save, print, all those options. Do, undo option here. Okay, so many
Mm-hmm.
options. So have you all understood this?
Yep.
Um, Srivardhan, are you understanding?
Yeah, it's clear.
Yeah. So can you just explain key what all things you have understood?
Yes. So I know the basic layout of the software.
Mm-hmm.
How to edit the toolbars, how to turn it on, turn it off,
Mm-hmm.
and in case I lose something, I can just restore the
Mm-hmm.
toolbars and their positions as well.
Mm-hmm.
And I get the planes, their positions,
Mm-hmm.
and how to start a sketch on the right on the correct plane.
Mm-hmm. Yeah,
And
that
I
is the
also
one sec. That is very important because like when
Mhm.
you're drafting, what happens is like some people just randomly select the planes. So what happens is first thing is like time. It'll take a lot of time. If there is
Mhm.
some part like this, I'll show you. I'll show you some examples later stages. I'll show you like how problematic it is when it comes to
Okay.
plane selection because it's a small thing. It's not a big thing, but it
Mhm.
makes a lot of difference. So, like for example, if you see this, there's like you can select any plane for that matter. Okay, so you can use top plane or front plane or anything. So some people use top plane, so they'll first make this thing they'll extrude it to whatever thickness, then they'll make this step, they'll extrude it, then they'll make this step, they'll extrude it. So it takes a lot of time. At the same time, if you're
Yeah.
doing taking the plane, at one shot you can completely complete this whole thing. Just one single shot you can complete this. Here and here you can keep fillet, work is done, and here one cutout.
Yeah.
This 2 3 steps you can complete these things. If you're using any other plane, it'll take 6 steps or 7 steps. So one more thing we should always remember as a designer is it should be whatever you're designing, it should be very simple. Okay, you should not
Mhm.
complicate it in any ways. In part body, here whatever in specification tree, whatever points there, it should be very minimal. Very minimal means
Yeah.
like it should be 3 or 4 or 5. How much of less steps you can use, so many less steps you have to use. Even if you're going for some interview, okay, interview point of view I'm speaking. So if you're going to some interview, they give you some model as a tool test. So what they before seeing the model, they'll see this part list.
Okay.
Okay, they'll see the part list how you have used what all tools you have used and how you have done it. So if you are like using a one step for one line, one step for one sketch, one step for this, that, this. If you're using like if you have 3 holes, and if you create one sketch, then one hole, then one more sketch, one hole, one more sketch, one hole, and like unnecessarily use multiple steps here, they like outright reject you. Okay, so it's very
Yeah.
important for you to understand that. In specification tree, you should be very minimal. Like how much of steps you can put together in one operation, so many steps together you have to put in one operation so that everything is in one place. You don't want multiple operation for one single phase. Okay, so what
Yeah.
happens is if you change somewhere, this whole thing will have to be changed. Every single thing one by one you have to change. Whatever design you're doing,
Yeah.
you should design it in a way. You should be like future ready. Future ready means you should be ready for any modification. If somebody comes and tells you to change this diameter, you should be able to change it in a second. Okay, if you don't do it in a structured manner, if you just keep multiple steps, what happens is if you change here, everything will be over constrained, everything will go out zigzag, and everything will change, every steps will change. You have hundreds of errors, one error on top of one error, one on top of one more error. So the whole errors you have to set in clean. So that will take lot of hell lot of time and patience. So at the same time, if you put
Mm.
everything in one single place, so when you're making the changes, you can change all those things in one single place. Okay, and you can just exit it. So your work will be done in a simple manner and very less time consuming manner, and they will be impressed too. So always remember, if you're going for tool test or anything, first analyze the design. That is what people don't do. Your competition won't analyze the design. They'll straight away start drawing it. They'll think, okay, time nahi hai, but 30 minutes is there or 1 hour is there. I'll start doing it. So they'll start to straight away do it. So you don't have to do that. Take your time, just analyze it. What all tools, how simple, like your main focus should be how to do it in a simple manner. That should be your focus. Okay, like for example, see, some people what they do is, see, if you have six holes, six holes with same pitch. Okay, what people do is they open the sketch. Okay, they open the sketch, they'll draw a circle. Okay, they'll create those holes. Holes means those circles. Okay, they'll create circles, and in sketch option we have pattern, right? In SolidWorks also you
Right.
have pattern option and sketch option. They'll give pattern option and sketch option, and they will extrude it. So what happens is they'll get the circle, the circular, the cylinder shape along with the holes. Okay, that is
Mm.
one example I'm telling you. So what he has done is a simple thing, right? He saved a lot of steps and he saved time also, right?
Yeah.
So, but in the actual process, do you think that is okay?
Uh, I mean, I think it depends on the whole kind of hole that you
Yeah. So
use, right?
right now, since you don't have the insight, so you'll feel okay. That is a right way to do it. I have saved time.
Yeah.
So when I say you have to simplify it, your mind will think like that. Oh, I should do it like this. So the moment you see that circle and holes, you'll think, okay, I'll do it in one single step, and it's good to go. So you'll do that. Okay, you'll create a circle.
Mm.
In that circle, you'll pattern those holes, and you'll extrude it, and the work is done. Okay, that it's a normal thing. So but in actual process, you're not supposed to do it. Okay.
Okay.
In actual process, what you're supposed to do is first just create the cylinder. After that, you have to create one single hole, and you have to use circular pattern in pattern. In pattern command,
Okay.
you're supposed to use circular thing. The reason being, see, if somebody comes to see, if the client comes and tells you, okay, see, this whole number, six holes are there, so the manufacturing cost is
Mhm.
going to increase. I just want four holes. So the person who has done it in Sketch, what he has to do is he has to go search the Sketch. Then in Sketch, he has to delete all those circles. After deleting all those holes, then he have to redo it, and he has to repattern. At the same time, you just have to go to the pattern option, and just here in the specification tree only, the numbers will be there. Just double click on the number and change it to 4. Your work is done right in front of the client. Okay, so going to sketch and or changing it is very unprofessional. So you have to just go here and double click that value and change the numbers to 4. Your work will be done. Okay, so you have to think like that. Modification point of view. That's why I'm very specific. You should think about modification point of view, and whatever you're doing, it should be very simple. And one more example is our fillets. So if you're doing a sketch, okay, so what this person will do is he'll apply all the sketches and all the fillets in the sketch itself, and he'll exit it.
Mm.
So and he'll pattern it. So in the future, like the person will say, this fillet is too small, enlarge it so that it's much more smoother at the curves. Okay, so what this
Mhm.
person has to do is, again he has to search for the sketch, he has to open the sketch, he has to delete all those things, and he has to again apply fillets, and he has to give different value and everything. It's again time consuming and unnecessary work. At the same time, if you
Mm.
just create sharp edges and if you give fillet option from part design in the part design workbench, so here in the specification tree you'll get the value. So double click on the value, change the fillet, and you're good to go. So that
Yeah.
is how you should think. Okay, simplification means like that, not to
Yeah.
double the work. Okay, so I wanted to clarify that so that
Okay.
you guys don't get confused. Okay, is that fine? And whatever I'm saying, it's not just for Catia. Okay, it's not at all for just for Catia. I'm telling
Yeah.
it in a like 3D design point of view. Okay, what I'm telling is like collective information for any 3D modeling. It is the same thing. Even you can enhance the SolidWorks design also using all these things. Okay, what I'm teaching here, same thing you can apply there also.
Okay.
Is that fine? Any
Yeah, that's
doubts?
fine.
Yeah, you're saying you can continue. You're saying something else.
Right now I don't have any questions.
No, no. You're saying right. You're explaining it. So I just briefed it out.
Okay. No, I think that's all I learned. Like
Okay.
I think I know I saw the different modules for various kinds of designing a part, right?
Hmm.
Uh, Mechanical and surface, different modules for HVAC and everything.
Yeah.
Yeah. So I just want to know, are we going to be learning all of those, or is it going to be restricted only to the mechanical design part?
Yeah, mechanical design, 6 workbenches.
Okay. Okay. Got it.
Okay.
Vishnu, I have a doubt.
Yeah, go ahead.
So if we are modeling in SolidWorks and we want to edit something in Catia, can we convert that into IGS file and take it to Catia and enhance the design in Catia?
Enhance the design in Catia. That is actually you have to create a step file. So in step file, after creating step file, you have to, like in Catia, if you do it, you can create step file. In SolidWorks, you
Mm-hmm.
have to give recognize. Okay, recognize. There's one option. So using that
Mm-hmm.
recognize, it'll recreate it. Recreate it means like it'll try to understand the design, and it'll try to
Mm-hmm.
create a model out of it. Okay, so
Okay.
that model you can edit
Oh, so
directly.
from Catia to
Yeah,
SolidWorks.
yeah, directly
But
you can't do
if I
anything.
want to, yeah, if I want to do it from SolidWorks to Catia, can I do it?
SolidWorks to Catia is very difficult. No, it's not possible. You
Yeah,
can
I tried
open the
doing
step.
it.
You can do it. You can open the step and step file. You can open, and still you'll have a lot of issues. You won't be able to do it. When Catia you can
Yes.
create step file in SolidWorks, advantages you have something called recognize. So
Mm-hmm.
using that, it'll recreate it. It will rebuild whatever dimension everything is there. According to that, it
Mm-hmm.
will automatically recalculate and rebuild it. So
Okay.
even there also is the same concept, but instead of human hand, the computer is doing it. That's it.
Okay. Okay. Got it.
Yeah. So anything else? Yeah. What did you
That's
understand? Like anything you can just brief it out. Whatever you have understood.
we just went through the different options that are available in Katia.
And not just that.
And
Like since Srivardhan is new, like anything, any important points that we discussed yesterday, you can just brief it out. Whatever you have understood.
oh, yesterday we just had an introduction of how when Katia came into existence and what are the advantages of using 3D modeling, like how it saves time and how we can easily modify the design before even entering the machining stage, and it is also economical and stuff like that. And we were also discussing on different sketcher part design and I mean options that are available. And I think we just went through like a brief intro on the sketcher and what are the constraints that are available. Like there are two types of constraints, dimensional and geometric constraints. And we went through part design and what are the options that are available. Since I knew it already, we just skipped, like skimmed through it.
Okay.
Yeah, that's yeah.
Any other points that we have discussed? Nothing.
We just discussed on Katia modules. So that is sketcher, part design, wireframe and surface design, sheet metal design, assembly, and we discussed how drafting is very important in before giving it to the manufacturers.
Mhm.
Like what is the importance of geometric dimension and tolerancing and everything.
Mhm.
Yep.
Okay. Okay, then I think we'll start with Sketcher Workbench introduction tomorrow. Okay, is that fine?
Mm-hmm.
Okay.
Yeah. So
Yeah.
try to get the software installed. So yours is installed, right?
Yeah, mine is installed.
I just sent an email to the support team, so I'm just expecting a reply with the link or something to download it.
Okay, you can take my
I
number.
can forward you the email.
Yeah, okay. You can.
Oh, you already have it.
Yeah.
Yeah, if you can drop your email here, I can forward the email to you.
Yeah, I'll just type it out.
Mm-hmm.
Just drop the email. Even I have to upload those videos. Let's see.
Mm-hmm.
When you drop your email, Prabha, you can drop your email.
Mine, yes. Yes.
Oh,
I have forwarded.
yeah, I got it. Thank you.
So just install it.
Oh, you can send to Gmail. I can give you my Gmail.
Yeah, you can give it to me. Okay, done. I'll upload
Okay.
the videos in
Thank you.
this. I'll upload the videos in
Okay.
this.
Mm-hmm.
Okay. Okay, then let's wind up. Any doubts or anything?
Okay. That's
Uh,
it for today.
Yeah, okay. Chalo then. Good night.
Okay. See you tomorrow.
Yeah. See.
Thank you. Good night.
Good night.
Good day for you.
See you.